I will run through the final numbers one last time just to be sure. Alright team, today we are diving into the topic of critical buckling stress. It's essential for understanding how our columns will perform under load. What are your thoughts on the formulas we use? I think the formula FCR equal to 0.658 power K into Fy is straightforward. It shows how the yield strengths play a crucial role. Have you both looked at how to calculate K? Yes, K equal to Fy by Fe. But what's important is how we determine the value of Fe. Exactly, Fe is calculated using Fe equal to pi squared E by K by R squared. The effective length K and radius of gyration are the key variables that influence the buckling behavior. Yes, I find it interesting how the slenderness ratio affects whether we use inelastic or elastic buckling equations. We need to ensure we are applying the correct conditions. So, if you have a high slenderness ratio, we typically see elastic buckling taking precedence. Agreed, we should also consider material properties. Different steels have different yield strengths, which will affect our calculation significantly. And what about the safety factors? How do we incorporate those into our designs? What about safety factors? And how do we incorporate those into our designs? So what do we do if we find our calculated FCR is lower than expected? So what do we do if we find our calculated FCR is lower than the expected load? So what do we do if we find our calculated FCR is lower than the expected? We may need to revise our designs. Revise our design. This could mean resizing, increasing the column size, changing the material or modifying the effective length to enhance stability. It's definitely a balancing act. Designing for strength while considering weight and cost. It sounds like continuous evaluation is key throughout the design process. It sounds like continuous evaluation is the key throughout the design process. Exactly. Always check assumptions. Don't hesitate to reach out for a peer review. If you are unsure. Collaboration can catch issues early. Don't hesitate to reach out for peer review. If you are unsure, don't hesitate to reach out for peer review. All right, let's wrap this up. How about we each prepare a quick summary on critical buckling stress for our next meeting? How about we each prepare a quick summary on critical buckling for our next meeting on critical buckling stress? Sounds like a plan. I'll focus on the implications of slenderness ratio in my summary. Good idea. I'll tackle the calculations for FCR. And how they apply in real world scenarios. I'll tackle the calculations for FCR and how they apply in real world scenarios. I'll look into different materials and their properties affecting buckling. I will look into different materials and their properties affecting buckling. Let's meet again to share our findings. Let's meet again tomorrow to share our findings. Looking forward to it. Let's meet again tomorrow to share our findings. I'll look into different materials and their properties affecting buckling. Let's meet again tomorrow to share our findings. Looking forward to it.